Hi everyone, welcome back to Aaron's Shop Notes. If you remember, we're in the middle of installing a TouchDRO system on the mill and the lathe. In the last part, we went ahead and talked about an overview of the system and how I'm planning on mounting the scales to the mill and the lathe. We also went over a case I designed for the Amazon Fire HD10 tablet that I'm using for the display for the DRO. In this part, we're going to go ahead and get the tablets mounted to the wall, and we're going to get the TouchDRO units mounted to the mill and the lathe themselves. Then we're going to go ahead and install the scales on all 4 axes on the mill. We won't have time to do the lathe today, but we should get the mill complete, and we will be able to go over testing, calibration, all of that. Then in the next part, we'll finish it up with the lathe. Now, if you're looking at this and you're saying, hey, there's already a tablet on the wall and there's already scales on the mill, well, that is because I forgot to film the intro before doing that. So there we go. All right, let's get started. So the backsplash is currently off, but for the lathe, I'm thinking right here. This will give me access to put it around here if I want, which will let me look at the cutter and the DRO at the same time. And if I want, I can pivot it this way towards the headstock. So we're gonna give this a try. It's easy to move if need be, but this should be good for now. So I just have these wood screws with the Torx head. I'm just gonna go put these into the stud. That is one advantage of having an exposed stud like this. Two little Phillips head screws here to secure it in place. Oh yeah, that can go right up near here. As far forward as I could possibly want it. It can go more towards over here if I want it further back, out of the way. And if I really want it near the tailstock or the headstock, over here, the typical mounting position. That is perfect. Cool. So the mill's definitely a bit trickier. I'm not entirely sure whether I want it on the left or right side. There's some documentation on the TouchDRO website that's basically saying it's better to have it on your non-dominant side. The problem is there aren't a lot of good mounting locations on the Bridgeport that are flat. Height-wise, I kind of want it up here, but there's not really anywhere good to drill and tap holes. I could put it down here, but that leaves it pretty low, especially if I put it on that side. And I'm just not entirely sure I want to commit to anything right now. So I think for now what I'm just going to do is I'm going to attach it to the wall on one of these studs, and now make it nice and easy to move in the future. And the worst that happens is I have a couple holes in the studs. So my plan, obviously this is going to go, so I think I'm going to move this whole collet setup to the left-hand side, and then I'm going to mount this tablet on probably this stud so that I can pull it out towards around here and have the readout around here. I think that'll be about right once I push the Bridgeport back in. All right, we had to adjust the spring, but let's adjust the tension. I think maybe we got something that's meant for too heavy of a monitor. I'm gonna break this, I gotta stop. I think that's as much as we're getting. All right, well, if I can adjust that more, I will, but for now, that's not too bad. Let's see, I still have access to this. Yep, so I have a low position, and if I want it, I have a high position. Maybe I'll be able to fix it, but for now, that's what I got. I can't do a in the middle. But I don't think that's too bad. That's pretty good. Yeah. Pretty good. Cool. Now for actually mounting the TouchDRO, we're just going to go right on the side here. The casting is relatively flat. We have the Y-axis is going to come out right here. We're going to put the Z right over here. X is going to come out right here. And the quill, that one will probably have to come down and around. But this seems like the most central location. So we're just going to go ahead and put this here. It's just 2 M4 bolts, so I have a size 30 drill, which is close for M4 tap drill size. And we're going to go ahead and get it tapped and drilled. All right, unfortunately we lost footage because my phone died and I didn't realize it. But the only thing you missed was I mounted the TouchDRO onto the side of the mill. I just drilled and tapped some holes. It was actually kind of eventful. I used this drill, and as you can see, it broke off right in the hole. Then I switched to a smaller size, one size smaller, and it was not cutting at all. I could not figure out what was going on. It turns out my drill bits just suck. This big old set of import drill bits is not good. It was not cutting at all. So I just switched to a 1/8, which is close to the M4 tap drill size of my nice Viking drill set. And that one cut with no issue. I went ahead and tapped it M4 and got it mounted. And I went with this side, which is something I already talked about, but obviously you guys missed that footage. I went with this side because X-axis is going to be right here. The reed head can come right out and attach here. Y-axis is going to be right here. Z-axis or knee we're going to put right here. The only questionable one is the quill, but we can probably just run it up and around and then down to here. Or we can run it back and around. So I think that's a nice central location for it. And that looks pretty good. There's a hole and a ding there from where the drill slipped when it broke, but I won't tell anyone if you don't. All right, let's get it mounted for the lathe. For the lathe, there's not a lot of good mounting options on the lathe itself. I could put it on the wall, but I think I want to put it on the lathe so it can travel with it. I think for now I settled on just going to, oh man. I'm gonna mount it to the back here and put a nut on the back side of this here door. I think that's the best option for now. It might cause issues in the future if the VFD wires cause noise in it, but we'll see. If that's the case, I'll just move it. So I'm just going to go ahead and drill and tap, or just drill 2 holes, clearance holes for the M4 bolts, and I'll show you when we're done because there's not much room to film here. All right, we got it all mounted. Nice and easy, just like we intended. 2 little holes, M4 bolt and nut. So everything closes as it should. And still closes without an issue. That looks good, just mounted to the back there. Nice and easy to route the wires there. Cool. Alrighty. So I'm going to show you how I went about mounting at least a couple of the scales on the mill because I think it can be informative. So to do this, I went ahead and supported the scale in the center with a 1, 2, 3 block. I then supported each ends with tape. Clamp would have worked here, but I just couldn't find mine. From there, I just went and roughly aligned it by measuring in from the top and bottom with calipers. I then could mark out the length of the slot with a scribe, and then after removing the scale, center punch one of the holes. After doing that, I could then drill it with an M4 tap drill size, and then tap using my 3D printed tap guide to make sure the tap went in straight, and we wouldn't have a weird crooked angle that would distort the scale. And on every single hole I drilled and tapped on this machine, make sure to blow it out with compressed air so you don't compact the chips and break off a tap in the machine. Technically, this axis should be the easiest since we're mounting both the scale and the reed head on the machine table and saddle surfaces, so we don't have to worry about indicating in the face of the scale that's currently facing us, just the top face of the scale. So to indicate it across the length, I just went ahead and set the dial indicator and an indicator holder and placed it on the mill table flat and zeroed it out on one end. I then could move to the other end, and since the table is a known flat surface, compare the readings and go back and forth until I had it within a thou or two across the surface length. Pro tip, if you're doing this, place the indicator base on a 1, 2, 3 block so it can move and slide easier. After that, it's just a matter of center punching, drilling, and tapping mounting holes for the reed head, making sure to use the 3D printed spacer we discussed in the last video to ensure correct spacing of the scale to the reed head. And then, of course, we want to move the table back and forth to make sure nothing is binding and everything looks good, nothing's pinching, all of that. All right, so let's talk about alignment, because this took me a while to get right, and I think this could be helpful. So if you look at the x-axis here, right, you don't actually have to worry very much about it being, if you run a dial indicator along this face, you don't really have to worry about that very much, because this is a machine surface and that's a machine surface down there, right? So the only thing you have to worry about is tilt this way, which you saw as I was installing it. We put the dial indicator on the bed to make sure it was flat from one side to the other. When you're installing on castings, like we are for the y-axis and the z-axis, you do have to worry about both faces. You have to worry about tilt in this direction, and you have to worry about this face here. So I spent a while trying to figure out the best way to do this, and I decided after a while the best thing that I could figure out to do was I took off the scale completely, right? And I put the dial indicator on the rough casting itself, and I made a map here of the readings. So what I was finding is that if I set this as my 0 here, we were about plus 10 over here, and we were minus 60 over here. So what that tells me is that we're kind of shaped like this, right? Curved inwards. So if you screw it in, what we were doing is we were forcing a bow inwards of this piece here. So because we were plus 10 here, what I did was I 3D printed shims to take out that bow. So because we're plus 10, I want that to be flat there. So even though this was 0, if we set this as our 0, we did plus 10 here. That'll set this as 0. And this was minus 60, so I printed this as a 70 thou shim. And the shape here, you can see, it's just like a full-size shim there. And now when you sweep the dial indicator back along the face, we're getting about, I think it's plus 6 or 7 thou across the 12 inches, which isn't perfect, but is a lot better than it was. When I was first doing it directly into the casting, we were getting about 70 thou. So that's how I did it. Maybe there's a better way to do it. I know a lot of people use set screws that you can screw in to use as offsets. I know a lot of people mount to a plate that has set screws on it, but I wanted to do it on the rough casting, so that's what I came up with. But hopefully this helps. The other issue is that when you put a dial indicator on it, there's no way to sweep along the entire thing with one dial indicator, so you have to keep swapping it back and forth, which is a huge pain in the ass. But that's how I did it. It took a couple hours to get right, but we got it. So now I have to do the same thing for the z-axis. So with the X, Y, and knee done, all that's left is the quill, which requires some disassembly. We need to get the quill nut off. To do that, there's a little cover up at the top for the upper stop for the power feed mechanism. We'll then take that cover off and come back to it later. From there, there's a small snap ring that we can get out with some snap ring pliers that sets how far downwards the screw can go, while still allowing movement for the power downfeed trip mechanism. Be careful with this, it's fragile. Next, we can remove the small pivot pin in the front that holds the pivot mechanism in place, which actually pushes up on the little rod and pops out the mechanism that engages and disengages the power downfeed. May require a small flathead screwdriver to pry it out. You'll need clearance to drop the whole screw assembly downwards, so make sure you move the stop nut up towards the upper half. And then finally, we need to remove the top mechanism for the upper stop for the power feed. A little M3 bolt just barely feeds into the end of the pin, so thread that on, and then you can pull the little pivot pin out. From there, you just need to push the little rod out, then the screw should be able to drop downwards after that. Now we can get to the big bolt holding the quill nut on, get that out of there, then pull the nut off with some pliers. I used some parallel grip pliers so I didn't mar it, but it might be on there a little tight. So now we need to do some machining of the nut. I set it on some parallels and tried my best to tap it down, but it's an uneven face, so it wasn't perfect. It doesn't have to be though. We can then use an edge indicator to find the center of the hole, and once you do that, always verify that it looks right visually to avoid scrapping the part that I only have one of. From there, it's just a simple matter of spotting and at the same time countersinking the top for the M3 countersink bolt that we're going to use here. Then you can drill all the way through with the tap drill size for an M3, and then you can come back and drill a clearance hole size in just the upper half of the nut. From there, we can just power tap the M3 down through the bottom portion. It just rides through the upper top of the hole since it's a clearance hole now without an issue. And then this part should be ready to take off the mill. Now to form the slit so we can actually clamp down on the 3D printed rod portion that will ride in the nut, I first tried with just a hacksaw. However, after some initial test fitting, I was finding that I wasn't able to clamp down enough to actually stop motion of the 3D printed part. Whether that was an issue with the slit or just because the small M3 bolt was trying to deform this big metal part. So the solution I came up with was just to come back with an angle grinder, and I enlarged the slot a bit, which meant we could get some more clamping force. If I had a slitting saw arbor, I definitely would have done this with the mill, but I don't. That's on the list of projects I need to tackle. So if you're interested in seeing that, leave a comment and let me know. And make sure you subscribe because it's coming up soon. With the enlarged slot and a little gronk on the screw, I found that it was not moving and looked good to go. To get the mill ready for attaching the scale, we just need to reassemble the downfeed mechanism in the reverse order that we took it off. First, the quill nut goes back on, making sure it still rides up and down smoothly. Then at the top, the small trip rod goes back in, and the small pin that goes through it and into the top of the screw. Keeping the M3 bolt barely threaded into the pin really helps here. Then we go back to the bottom, where the lever arm goes back in place, and the threaded pivot pin that holds it in. This should still move very freely at this point. Then finally, the snap ring again. Again, be very careful. These are fragile. Ask me how I know. And of course, after the snap ring is in place, we want to make sure that the trip mechanism still works. So just go ahead and engage the power down feed, and then manually press down on the stop nut and screw assembly to make sure it still kicks out. Now, to install the actual scale, I actually struggled a lot to get these to thread on. Eventually I figured out there was some imperial thread that almost matches the M3 bolt I was trying to use, and they seem stripped out, most likely from my efforts. So I just went ahead and removed the bottom pivot bar again, and then pulled the trip rod out so I could drill and tap these two holes for an M4 bolt. If you can get away with the holes that you have there without doing this, go for it, but it was not working for me. So to get that pivot pin out, you just need to push it. It's probably stuck with grime and grease and stuff. I just pushed on it with a little flathead screwdriver, and then grabbed it with some needle nose pliers to actually pull it down. The only thing to watch out here for is that the threads on the bottom bolt, if they are too long, they will rub on the rod that you just pulled out and stop the trip mechanism from working. So make sure you check for that. Once you drill and tap it, go ahead and thread a bolt in, and then put that trip mechanism back in and make sure it's not rubbing manually before you put the rest of it together. I actually had to pull mine out and shorten the bolt a bit. I really cannot emphasize enough how important it is that you check that the trip mechanism works at every point when you're reassembling here. You really don't want to get the entire scale on and then realize you have to take it apart again. So now we get to attach the plate that acts to mount the scale to. And remember, this is the piece that we plan on getting made from an aluminum piece from Senket Sand, but this is just for a test piece. It actually is fairly stiff with the way I printed it with 10 wall loops and 60% infill. It's pretty much all walls. So we're just going to get this attached with some M3 countersunk bolts, and once that's in place, we can go ahead and start attaching the scale to it using the two heat set inserts that we have at the top and the bottom. For attaching the 3D printed portion that couples to the nut, you want to leave the scale loose in the slots. Then the best order to do this is to run the bolt through the quill nut, again leaving it loose, then attach to the back of the reed head, then go ahead and tighten those two bolts down, and then set the inwards-outward spacing and tighten down the bolt that clamps into the quill nut, and then finally the left-right spacing by tightening down the scale within its slots, making sure that the spacing is correct. And of course, After all that, make sure it still rides up and down smoothly. So great, we're done with the quill, right? Well, not quite. So we got the quill mounted, and I'm pretty satisfied with it overall, but there are some issues. As you can see, the clamping force, I guess, just wasn't enough to actually close down on this. You can actually push this in and out. Luckily, I think the scale is pretty robust to that. It looked like in the spec sheet we can go plus or minus 1 millimeter, which we don't have there. But I would like to fix that. The other thing is this flexes a lot, and when it flexes, you can see the scale actually is changing values, and I don't like that. So I want to beef this up. So I'm going to go ahead and make a couple design changes in CAD because the intent was for this to always stay 3D printed. I'm going to make those changes. I think now that we see it on the scale here and I know where the position is, I don't need it to be slotted. So instead of trying to clamp down on it, I think what I'm going to do is I'm just going to turn it into a hole at the correct location here. I'm going to go ahead and mark with a Sharpie, pull it off, and then that'll tell me where the hole needs to be. And I'll put a threaded insert in here or a flat or something on this thing. And then we're going to also beef it up with that fillet so that it flexes less. So that's how we're going to handle that. I'm going to go ahead and make those changes and get it remounted, and hopefully it'll be better. I'll show you when we're done. Able to come up with for fixing the mounting of the reed head for the quill. I redesigned it, so I got rid of the slots for this hole, right? Because we have the slots up here and attaching the reed scale, and I determined that those would be enough adjustment left to right after actually seeing it on the machine. Additionally, we got rid of the slot in the hole here, and reason being is we were able to take measurements with it on the machine to see what the right spacing is. So I didn't need it to be adjustable because using the old design, I was able to figure out where the hole was supposed to be. So what I did was I went ahead and got rid of that slot, and I made this a through hole for a M4 heat set insert. So we're just going to run a M4 countersink bolt, same one that we were using before, to try to close this gap. Now we're just going to run it into this heat set insert here, and that should be a much more rigid connection. Additionally, we added some material here to the fillet and to the overall device, and we're also coming around the front here. So this gap right here, this 2 millimeters, is how much we should have in the front here based on the mounting location for the drawings. So rigid connection back here and here, and then we can use these 4 M3 countersunk holes that I didn't know were there from the drawing, but are actually on the device to attach to the reed head here. Then what I designed it so that wherever it sits, there should be a 0.5 millimeter gap here to here. That will maintain the correct spacing of the reed head to the actual device, to the scale. Then what we can do is we can just set that gap using shims when we adjust the top and bottom bolts here along this slot. And that'll make it so we have nice clearance along the top and bottom, and everything should be good to go. So I'm going to go ahead and get this printed out of ABS glass fiber again with 10 wall loops and 60% infill. I found that gave me some very good strength. And once we get it printed, I'll go ahead and get it installed, and we'll talk through it again and see if it's good to go. Now, getting this mounted is very similar to the first way that we did this. We're going to leave the scale loose left to right, slide the reed head out of the way, and then place the 3D printed part into the nut. This is a nice tight fit, and once that's in there, there's only one way it can go because it's not slotted anymore. So we can then run the screw down through the quill nut into the heat set insert on that 3D printed part loosely. Leave it pretty loose here, but snug down. From there, we can then slide the scale down. This should be a nice tight fit, which was intentional to add some rigidity. And then we can loosely run in the 4 countersunk M3 bolts in the front here. And then we can then go to the back and put in the 2 M4 bolts, again, setting them in loosely. At that point, we can then go and incrementally tighten the 2 M4 bolts and the bolt holding into the quill nut, all 3, one after the other, so that sets the position correctly. Which of course then just leaves the 4 and 3 countersunk bolts in the front that we can go ahead and finish tightening down. Now, to get the scale set in the correct place, Remember in CAD I modeled it so that there was a 0.5 millimeter gap between the 3D printed part and the scale, which would set the correct gap between the read head and the scale. So to do this, I went ahead and ran it down, the quill all the way down to the bottom, and set a 0.5 millimeter shim in there. I then tightened the bottom bolt that was holding it in the slot. I then ran it to the top and tightened the top. And then I could run it up and down and make sure that I still had the same spacing that I needed everywhere. And then finally, we can run the quill up and down, make sure it's not binding anywhere, and make sure everything looks good. Now, to verify this, the easiest way is to make sure we have repeatable measurements once we run into the stop on both sides. So if we go ahead and 0 the DRO, we can run to the top, and when we're pressing against the nut up there, we're reading 4.698. Go all the way down, and with no pressure, reading 0. And if we test that a few times, we should get repeated measurements, which it looks like we are. So I'm very happy with this. This is a lot more rigid of a setup than before. So as I was explaining in the CAD, this is what we have now. We're attaching to 4 points in the front through these countersunk M3 holes. We sandwiched the entire thing, still attaching in the back. We thickened it up, and now we're threading into a heat set insert in there. I wish I hadn't made this ugly slit in the side, but you know, everything's 20/20 in hindsight, right? We have the same, the set gap along the side. I think this is going to be good. Really happy with that. All right, so let's talk about calibration. We already have this all set up, right? X, Y, Z, quill, everything is set up. The quill and the knee are set to sum together. All of the axes are set up parallel and indicated in. So how do you go ahead and calibrate it? There's a video on this that I'm going to link, but from Yuri himself, but I'll go over the general procedure here. First thing first, we have a set surface here, a 1, 2, 3 block clamped down to the table. That's not going to move, right? So what we're going to do is we're going to drive in, and we're going to go to 0. We're watching our x-axis right now, right? We're going to 0, and what we're going to do, once we're right on 0, we're going to 0 it out there. And what we're going to do now is we're going to make sure that our axis is repeatable. We're going to make sure that we can approach it from both directions and still get back to the same 0. So we'll go from this direction first, drive back to 0 on the DRO, make sure that's 0 on the axis. So that's about 1 thou out, right? Let's try that again from the same direction. 1 thou, same reading. Let's try it from the other direction. So that we're able to get back to 0 consistently. So let's try that again, make sure it's not an issue with our measurement. Okay, so that's consistently 1 thou out. So what do? That's called hysteresis. In the axis, we're going to go into axis settings, encoder hysteresis. So this is like a sort of memory, a backlash for electronic devices. So what we're going to do is we're going to go ahead and adjust that, right? Right now it's set to 1. Let's go ahead and set it to 0. This is number of steps, encoder steps. Yuri talks about this more in his explanation, but if you want a better explanation, go watch his video again. I'll link it. Let's try that again. Let's go ahead and go to 0. Zero it. See if we can get back to 0. Zero, exactly, right? Perfect. All right, let's try the other direction. All right, so that looks good. I'm going to mess with this more off camera, but that's what you're looking to see, is that you're able to return to 0 repeatedly from both directions. So what are we going to do now? We're going to go ahead and we're going to calibrate this. So if we go back into settings, we'll go to our axis. You can hit this calibrate button. It's going to want you to tell you what dimension of the calibration block you're going to use. We're going to use a 246 block. We're going to use the 6-inch side of it because that's going to be the most accurate calibrating over a long range. So we're going to put in 6 inches. It's going to ask you to locate the left edge of the calibration block. So we're going to drive to 0. We're at 0, hit continue. It's going to take a bunch of encoder readings to make sure we have a consistent reading. Now what we're going to do is we're going to drive to that same 0 reading. Okay, continue. Same thing, it's going to read the axis. Okay, gives you a calculated resolution, 5079 or 5 micrometers per encoder step. That's good, right? We have a glass scale that's 5 micrometer resolution on the tick marks on the glass scale. If that was considerably different than that, that would be something is wrong, right? Something is weird is going on, our axis is not set up properly, the mounting is not correct, something like that. The fact that that's close to 5080, which is the nominal value, is really good. So I'm going to trust that, I'm going to hit apply, and now we can retest repeatability. So we're at 0, right? Let's go ahead and 0 it there. We're going to move in, let's say, we're going to drive to 0.2 here, or let's say 0.5, right? You better hope you see 0.5 here, which we do. So, looking good. Repeat this for all 4 axes, and you're done. All right, that's all we're gonna have time for today, but I think it was a really productive day. We got all of the scales installed on the mill, as you saw. We got the cables routed, we got the tablet and the TouchDRO installed, and we did some testing and calibration. I think that was a great day. Also, we identified a problem with the mounting of the quill, and we fixed it. So I'm a lot happier with that design than I was with the previous design. So I think this is looking great overall. If you enjoyed, please give me a like. A subscription would be greatly appreciated, and I'll see you next time for mounting the scales on the lathe and finishing up this project.